Alright, so let's go ahead and take a look at the first one. How many in the fifth figure of the pattern? So we're going to make a table, draw a graph, and write an equation. So fifth figure in the pattern. So this would be the first, right? Second, third, fourth. And then it's asking for the fifth figure in the pattern. Well, let's see how many blocks there are. Let's see how many it starts with, right? So it looks like it starts with 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to look and see how the pattern's changing each time. So it looks like each time that it's being added by 2. So 9 plus 2 would make 11. Now, that wasn't too bad because it only asked for the fifth figure. But what if it asked for the 5,000th or 5,000,000th figure? Well, I really wouldn't want to, write that out that many times. And so what we're going to look for is we're going to look for a shortcut. We're going to look for a rule that describes this particular pattern, because every pattern is different, because it starts with a different number of blocks, or maybe it goes up by a different amount. So we want to find the unique or specific pattern that fits, or the rule that fits this specific pattern. So one way that we do this is that we try to organize the information so we can spot the pattern. So we're going to start with a table, and in some ways I've actually already written the table. If I say this is my x and y, so I'm just taking, for the first figure there was 3 blocks, second there was 5, 3, 7, 4, 9, and 5, 11. So I'm kind of taking what I'd already written here, I'm just putting it in the form of a table. One thing that I could do with that from there is I can graph it. So if I said that this was, let me scroll down here a little bit, there we go. So along the bottom here, if I've got 1, 2, 3, 4, 5, and then this one, I start at 3, so 1, 2, 3, and then it looks like it's jumping by 2 each time, so we could say 5, 7, 9, and then the graph kind of goes off the chart here a little bit, so we'll just kind of use our imagination. 11 would be a little bit above that line. So then if we put in those points, so I've got 1, 3, 2, 5, 3, 7, 4, 9. Oops, that would be 4, 8. 4, 9, and then 5, 11. So let's use our imagination there a little bit. Alright, so it's a linear relationship, and we'd say that it's a linear relationship because, well, one, if you look at the picture, it's in a straight line. The other thing that we could have used to tell us that this is a linear relationship is that let's look at how it's jumping each time, right? So the numbers jump 3 to 5, that's going up by 2, 5 to 7 going up by 2, and then going up by 2. So something that has a linear relationship, and maybe we just make a little note of this, something that has a linear relationship, it is linear because it increases, right? So it's a linear relationship. It increases at a constant rate, or changes at a constant rate. I don't want to constant. I don't want to say increases because it may not always increase. Maybe sometimes it decreases. This particular one increases, right? So it increases at a constant rate. The other thing that we kind of then figure out is, well, again, what would it be if we wanted to know the 5,000th term in that sequence? So we're looking for an equation, and we're looking at what happens to each y that turns it into an x. The reason why there's a little machine up there, if we look, I think up there at the top right, you almost kind of think of what happens here is that an x goes in, so let's say 1, and then he comes out at 3. And then the question is what we're trying to say is, well, what's happening in there? What would change a 1 to a 3? What would change a 2 to a 5? And what we're saying is that by some operation, by multiplying, adding, subtracting, we're saying kind of what's going on there. And you think, oh, well, maybe it's plus 2, right? Because 1 plus 2 is 3. But then 2 plus 2 is 4, not 5, right? So it's not by adding by 2. Well, so there's kind of a shortcut that we can use with this, is that, I mean, we can do kind of a guess and check and kind of think about, well, what if I multiply this or add that? But there's actually a more direct way of doing it. The number in front of x, right? So x is being multiplied by some quantity or some amount. That would be the rate of change. So I'm going to write in rate of change. So the rate of change, for instance, in this one is plus 2, right? Because you see that it's increasing by 2 each time. So that's where I would have y equals, let me erase this. So that's where I would have y equals 2x. And then what the last number there, what we'll represent here is if I counted backwards, and if I wanted to say, okay, at 1, 3, and it's going up 2 over 1, what if I went backwards? Well, that would be down 2 over 1. So when x is equal to 0, the y would be equal to 1. So I would actually say y equals 2x plus 1. And then I can test that out. And the reason how I can test that out is that if I said, okay, well 2 times 1 is 2, plus 1 is 3. Okay, that works. 2 times 2 is 4, plus 1 is 5. So again, let's make sure we understand where these numbers came from. The 2 came from looking at the table and seeing how it changed by the same thing each time. So that number, what we'll refer to as our slope a little bit later on, that's our rate of change. So it was adding 2 each time. Where'd the 1 come from? Well, what I did is that this is the value of y. It's almost kind of like counting backwards. And so instead of saying plus 2 each time, we're saying, what if you counted backwards to when x was 0? Well, then that means that y would be equal to 1. So what we could say here is we could say the value of y when x equals 0. Now obviously we could have done kind of a guess and check thing to figure that out as well, but this is more of a direct route. Alright, so take a moment, pause the video now, and try 1.2 and 1.3 on the right side there, and then when we come back, I'll show you what the answer is so that you can check your work. Alright, so let's check your work here. If you take a look at 1.2, you should have got that the fifth figure would have 30 little circles in it, and that the equation describing that pattern would be y equals 5x plus 5. And then for 1.3, the fifth figure would have 17 rectangles, and the equation describing that pattern would be y equals 4x minus 3. Okay. All right, so we'll go ahead and conclude the first problem.